going on with our packet involving the central limit theorem, I want to talk a little bit about this potato chips problem just to get you started so you can work on it. Then I'm going to go on to the smokers problem a little later, and so that you can work on that as well. Then that way tomorrow in class we can just talk over any questions you have, go over any of the things we need to. So suppose that the weights of bags of potato chips coming off an assembly line are normally distributed with a mean of 12 ounces and a standard deviation of 0.4 ounces. And that's what I do first. Notice that the potato chips have follow a normal model. So it's not skewed, it's not, the population is normal. That is important for us as we go on and answer these questions and we have different size samples and we look at sampling distributions of the mean. So in part A, what is the probability that one randomly selected bag weighs less than 11.9 ounces? We're talking about one individual bag from this normal model. So the symbol you would use to find this, we're looking at the probability that X, not X bar, because we're looking at one randomly selected bag. So we're looking that X is less than 11.9. So you're going to draw a picture, sketch out your normal model, and use our strategies that we've done. I'm not going to talk about the next question. I think you can get that okay. Then for this next part, calculate the probability asked about in the previous question. So the previous question was involving a sampling distribution of the sample mean because it is involving a sample, I think we said 10 bags. So we had a sample size, N was 10. So you're going to need to know that. And then also when you use your symbol, we're looking at the probability. Now it's not a single bag anymore. It's an average of our sample of 10 bags. So the correct symbol is to use X bar is less than 11.9. And remember what changes. It's still going to be a normal model. Your mean is still going to be 12. But your standard deviation is going to be different. So think about that. I'm not going to fill that in for you. Then you're going to go on and do for 100 bags. Then you would do for 1,000 bags. And so that you should be able to do, okay? Then you get to this problem, part F. What is the smallest sample size for which the probability of the sample mean being less than 11.9 ounces is less than 0.01? And what you're going to have to make use of for this part is a z-score. And if you recall from when we did z-scores before, to calculate a z-score, you take x minus mu over sigma. That was in general that we talked about before. But now we're talking about the sampling distribution of the sample means, and we're talking about, changing our mean and standard deviation to reflect that, or the mean stays the same. So I'm going to adjust my standard normal formula. So z equals x bar instead of x, because we're talking about a sample mean, minus mu sub x, which is just going to be the mean of our population, divided by sigma over the square root of n. Because remember, this is our standard error of our sampling distribution or our sample statistic when we are dealing with the distribution of the sample means. So when you look up, we want to find the probability, we want to find a z-score that gives us the probability of being less than that gives us a left tail of 0.01. So let me show you how to find that value. And let me turn off whatever is doing that. Okay, so in our normal model, now I can't, when we don't know n, so we can't necessarily mark off mark off our normal model, but what I'm looking for is where is that z-score so that this area down here is 0.01. So if you go to your calculator and you do second distribution, and we want to do inverse norm. The area has to be to the left, so it's 0.01. And we want the standard normal. So remember, for a standard normal distribution, the mean is 0 and the standard deviation is 1. So we want to leave that as our mean and standard deviation, and then come up with what that z-score was. So this value right here for z that would create this would be negative 2.33 if I round to 2 places. So we're going to actually fill in some of these values. So for z is negative 2.33. Well, I know x bar is 11.9. I know the mean, mu sub x, is the same as the mean of the population, or actually, we're really dealing with mu sub x bar, but it's the same as mu sub x. So we end up with 12. And then my standard deviation, sigma, is 0.4. I don't know n. That's what I want to know. Notice here I have this equation, and I have one unknown. You need to solve for n. I'm going to leave it for you to do that. Just think it through. I have confidence in your mathematical ability. In this next part, if they just ask you, if you read through, if you were told that a consumer group had weighed randomly selected bags, found a sample mean weight of 11.9 ounces, would you doubt the claim that the true mean weight of all the potato chip bags is 12 ounces? Look over your past work that you've just done dealing with this problem, and then the question, on what unspecified information does your answer depend? So ask yourself, well, what probability would be surprising to me and make me doubt the claim? And so what is it that's changing my my different answers for the different probabilities? So kind of think through that when you are answering this question. All right, so then as we go on to this next one, which of your above answers 2 would be, got a little grammar going on there, affected if the distribution of the weights of the bags was not normal? So what if now it wasn't normal, but it was skewed? Then you have to think about, what were our conditions in order to use a normal model? Because if our population wasn't normal, then some of the calculations we made we wouldn't be able to make, and some of them we could. So you have to go back and think through that. Then on this next question, what is the probability that the sample mean weight from a sample of 50 randomly selected bags would be between 11.89 and 12.11? Well, I want to just come up with the symbols that you would use, what you're trying to find. You're trying to find that your x bar value is in between these two amounts. So you're going to create your normal model. Okay, now we're going back to the idea that it would be a normal model. However, even if it wasn't, look at your sample size. So think about what your mean and your standard deviation is going to be of this normal model of our sampling, the distribution of our sample means with a sample size of 50. Draw a picture, mark off your 3 standard deviations going each direction. Remember that your standard deviation for this problem is not 0.4. So if you need to go back and think about that. And then you do a similar approach on part J. Okay, this one, part K, give it your best shot. Go ahead and try those. I'll tell you right now, on part K, you are going to have to use that formula that I talked about, where z equals x bar minus mu sub x over sigma over the square root of n. So you will have to use this strategy when you go through and do that. Then on part L, you are determining a sample size, which means you're also going to have to use this formula up here because you're trying to determine a sample size. So you're trying to figure out a value for n that would give you particular results. Okay, so kind of think through those. So I do want to get into the next problem just a little bit because I have no idea what tomorrow will be like in class. And I want you to at least have looked at this so that we can kind of finish talking about it tomorrow. So this one, we're making a shift now. The potato chips problem, as well as the grade distribution, was dealing with means. And now we're changing that, and we are dealing with proportions. So that means, and you know, we've talked about this, but remember the handout I gave you that showed you the formulas that we use for the distribution of the sample proportions, and we had that on the left side, and then on the right side, it was the distribution of sample means. And now, though, we're going to be going to the proportions, because now we've just done a couple of examples with means. Now we need to be looking at proportions. So remember for this one, our mean of the p hats was p, and our standard deviation of p hats was the square root of p times 1 minus p over n. Okay, so this is what we're working with. So instead of the x bar, instead of the mu sub x bar equal to mu, and the sigma x bar being sigma over the square root of n, which we just did, now we're using the proportion formulas, still the central limit theorem. Remember, we had conditions for that. You can go back and look at those that we did. So you'd be able to answer some of these questions going through that. So what symbol would represent this proportion of 0.229? Well, they're telling you that this is for all, this is the Center for Disease Control, or the CDC, reporting this for all Americans who smoked regularly in 1998. So because it's the population, we could actually use this as P. So P equals 0.229. Suppose that you take a random sample of 100 American adults. Will the sample proportion of smokers equal exactly 0.229? Well, you should know the answer to that and a reason why, so I'm going to leave that one for you. What does the CLT, now CLT stands for Central Limit Theorem, what does that say about how the sample proportion of smokers would vary from sample to sample? So remember that we said when n is large enough, okay, so when n is large, then the sampling distribution of p hat will be approximately normal with a mean of 0.229, it's the same as p, and the standard deviation is going to, for this problem, would be 0.0420, because what you're going to do is you're going to take the square root of p times 1 minus p, which is 0.771, divided by n, and that's where I got this value. Okay, so this would be, notice the approximately normal, because my distribution is not normal. So, by the way, the distribution, because people either they smoke, or they smoked regularly, or they didn't smoke regularly, so we have those two outcomes. So we're looking at a Bernoulli, and we can kind of consider this like a binomial model. So, but as long as n is large enough and the conditions are met, we can use an approximate normal model. So then you should be able to answer that. Okay, I do want to talk a little bit about z-scores for this in this part where it says using the central limit theorem result, find the z-score corresponding to a sample proportion of smokers equal to 0.25. Even though we don't use the z-scores a lot with our calculators, you still need to know those and what that means. So it's still important. So here's the formula we're going to use. I'm going to adapt this formula here. We're going to have our p hat minus our mu sub p over, which is just p. So I guess we could just write this as p. Over the square root of p times 1 minus p over n. So this is our formula. Remember, this is in general. Remember what it was? It was x. When we first learned about z-scores, we had this, but this was with means. Now we're dealing with proportions. And then I showed you just a little bit for the potato chips how we adapted it. Well, this is how I adapt it for this particular technique. So then from here, you're just going to plug in numbers. So your p hat, this is your p hat. So you can do that and figure out the z-score. Then once you've done that, use this z-score and the table of normal probabilities. You don't have to do it that way to calculate the probability that the sample proportion of smokers would exceed 0.25. Now we're talking about a sample proportion. So my notation I'm going to use and my symbols, I want a p hat exceeding 0.25. So I'm looking for this probability. You can actually build your normal model with these values right here, except this was when n was, what n is, this was with n equal to 100, remember? And here, are we still dealing with that same one? I guess we are, still 100. So in this one, it's still 100. So you're going to use this normal model. You can draw a picture to support your work, 3 standard deviations each direction. Find the region that's greater than 0.25 and shade that, and then use a normal calculation on your calculator. That's fine to do as long as you support it with some work. Then think about what's going to happen if you take a random sample of 400 adults. So now your value of n is increasing to 400. So think about what that's going to do. Your mean is not going to change, but your standard deviation will change. Then they ask you to do it for 1600, but you should be okay on that. And then the very last part of this asks you some questions where we're kind of going to make some inference. You should be able to go through this. They give you a new proportion because now we're not doing the whole United States. We're just looking at the state of Utah. So we have a new population proportion. And so now we're going to go through this technique using that information instead. So hopefully that gives you an idea of what to do to kind of get through the rest of this worksheet, and that will streamline our efforts tomorrow to get through all of this.